the letters A and C, that gives C 1 over x, 1 over x, 1 over x. So therefore, these two triangles are similar. Again, this must be TU, and this must be US. Typo error for your book. So if all the sides are proportional, 3 pairs of sides are proportional, again, we're always dealing with fraction here, then the two triangles are guaranteed to be similar. The last shortcut is the Sas Similarity. If the measures of two sides of a triangle are proportional to the measures of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So you're given with two sides that have a measurement, and the included angle is the angle in between the sides with the given measurement. So Q and T are the included angles here. Q is between A and C, T is between AX and CX side. So if you get the ratio of A over AX, that's 1 over X. If you get the ratio of C and CX, that's 1 over X. So with respect to these two pairs of corresponding sides, they are proportional because they become 1 over X. Both of them is 1 over X. And then with respect to the given angles, it happens that they are equal. So by Sas Similarity, we can say that PQR, triangle PQR, is similar to triangle STU. Okay? Clear? So I will just explain one example here before I end this short video. So I'll be solving the example. Check your progress on under example number 2. Okay, so we have find WR and RT. So we need to find the X first. So first is you pair them properly, corresponding side. We know that these two angles here are congruent because they are vertical angles. So these two angles are congruent because you have to know how to pair up the side. So if these two angles are congruent, that means S and V are also congruent. Okay, so that's from AA similarity. If these two are congruent, it implies that the other two are also congruent, the S and the V. So that means the side that corresponds to WS is the side from that angle with single curve to the one without measurement. That is not part of the vertical angles here. So it's WS over VT. Okay, so WS over VT equal to WR over TR. Okay, so this is our proportionality statement. That's our equation. We see fraction equals fraction. When we deal with similar polygons, we always do fraction equals fraction. Write them properly, and then we do the next step, which is cross product. So we replace them. What is WS? 8 over 10 equals x plus 6 over 2x plus 3. Okay, cross product. Now 8 over 10, you want to make it smaller, it's okay. So you can make this number smaller. That becomes 4 over 5 equals x plus 6 over 2x plus 3. Cross product. So 4, move the 2x plus 3 here, equals, move the 5 to the other side, but since there's two terms here, you have to enclose this in a pair of parentheses. So that is 5x plus 6. So that gives us distributive property 8x plus 12, 5x plus 30. So do the algebra. Minus 12, cross out. So that gives us positive 3x is equal to 18. divide 3, divide 3, so x is equals to 6. So x is equal to 6. So the problem is find WR and RT. So now we replace this x to the measurement of WR. So WR, this is the one in your classworks. These are the indicated sides. The sides after the number, that's the one you go back and replace the variable. You don't just find x and then done. If the instruction says find the indicated side, then you replace it to the one written after each number. So WR and RT. It's clear here that we have to find WR and RT. So WR is x plus 6. That is 6 plus 6. So WR is equal to 12. And then RT is equal to 2x plus 3. 2 times 6 plus 3. RT is equal to 15. Okay? So with x equals 6, WR is 12, RT is 15. So we have, just to go back to the similar polygons last time, scale factor. We are not asked to find the scale factor here, but I just want to show you scale factor. You get one fraction, either use 8 over 10 because it's already there. So 8 over 10, simplify it, 4 over 5. Or let's say you want things to be complicated. I'd rather use the one with x. So since you already have the x and you have the values of these, that's 12 over 15 divided by here. Simplify this, divisible by 3, divisible by 3, common divisor, greatest common divisor is 3. So we have 4 over 5. Still ends up to be the same. 4 over 5. So we use this, it's 4 over 5. If you use this, it's 4 over 5. And see, because they're similar, after you did everything and you have now the value of all the sides, they should end up to be the same. Although it's 8 over 10, this one is 12 over 15. But if you simplify that, that is 4 over 5. And that makes them similar because they are proportional. So in your classwork, I hope you understand, and I hope that helps you answer your classwork. Let's just go over to check your understanding. Check your understanding. We have this one. Number 1, determine whether each pair of triangles is similar. Justify your answer. We're given with 2 sides and an angle. You see, we're given with an angle here in between 10 and 5, in between sides with measurement. But here, the angle that is given is not in between this 8 and 4. So we cannot use SAS over here because the angle is not an included angle. So automatically we say this is not similar. What about this one? No angle measurements are given, but all the sides are given. So we check if they are proportional. So we see. So how do we pair? Can do the biggest over the biggest, and then going down to the smallest over the smallest. So 25 over 8 and 1/3. So 25 over 8 and 1/3. 25 over 8 and 1/3. Let's just write them first. 21 over 7. And then 9 over 3. These last two fractions are quite easy to simplify. 21, 3 over 1, 3 over 1, or 3, 3. What about this? Mixed number. 3 times 8, 24, plus 1, 25 over 3. So 25 times reciprocal of your denominator is 3 over 25. Cross out 3 over 1 or 3. So we check SSS here because all sides are given. So we check if SSS is applicable and ends up that all are the same. So by SSS, these two triangles are similar. Okay. Number 5. Okay, number 4. Let's do number 4. We have find x. And the measures of the indicated side, you're going to find DE. And then in number 5, after you've solved for x, you find AB and DE. You replace the x. Here, we pair up x. So if I want to start with the x side, x corresponds to what side on the other triangle? You see the x is in between, is the side wherein it ends with a single curve and no curve. So that means the corresponding side of this x to the other triangle is on the side in between a single curve and no curve, which is 45. So that is x over 45 equals to another pair of corresponding sides, 3 over 15. So solve for x. Cross product, 15x equals 3 times 45. I don't know, it's too big for me, so just leave it like that and divide both sides with 15. But I can see these two can cancel out numbers here, so there are 3 15s in 45, so the 45 becomes 3, the 15 becomes 1, so 3 times 3, 9. So x is 9. So if x is 9, DE is equal to 9. Don't say x is 9 equals DE. That's a laziness. You have to write it as a second answer that DE is equal to 9. How about number 5? Number 5. Right there. There. It's clear? Number 5. So find x. X is corresponding to the single to double, x minus 4. Because figures are not always drawn in the same manner. They were sometimes the other one is turned left, reflected, rotated. So you have to know how to pair up the sides properly.